understanding work, energy and power. This is a 3-part video series where first I will bring you what is work done, in the second video I will tell you what is energy, and in the third video I will explain you what is power. I know most of the students confused with this, that's why I decided to cover this in a video. So before starting to learn what is the meaning and the connection between them, press on that subscribe button and hit on the bell icon so you won't miss any future videos we upload. So let's start. If an object changed its position or shape under a certain force, it is said to have work done. Let's take a basic example. Think that there is a box on the table and you need to move it into here. So what will you do? I would have just pushed it. Yes, you keep your finger and push it with a force of 1 Newton for 1 meters. Remember that in physics always use meters, not centimeters, not kilometers, and possibly not decimeters. Okay, now what is the amount of work done? Then comes this equation where you must keep in your mind. Work done is equal to force multiplied by distance moved. So substituting the way you moved the box, we get 1 Newton times 1 meters. So work done is equal to 1 Newton meters. Always pay attention to these quantities. Either it is 1 meters per second or Newton meters per second or anything, you must pay close attention to how you manipulate them. So here the answer cannot be kept at 1 Newton meters. Instead we write 1 joules. Now take a notebook and write 1 Newton meters is equal to 1 joules. Now let's move into another example. I want you to pause the video and calculate this. Okay, so here as same as before, we use the equation work done is equal to force multiplied by distance moved. It is 3 newtons times 5 meters, which gives us 15 Newton meters. We can't keep it in Newton meters, so we write it as 15 joules. So the work done is 15 joules. Now let's move into our third example. This is a bit complex. Have a look. The mass of an object is 5 kilograms. Find the work done in lifting it upwards by 3 meters. So if you want to give it a try, pause the video and continue. First, let's graphically represent this information. Here, instead of giving the force, they have given the mass. So you must be smart. I know you have learned the Newton laws. This is where Newton comes into play. F equal to ma. So let's substitute this equation to find the force applied. So the mass is 5 kilograms. What about acceleration? They haven't given any acceleration, right? No, they have indirectly said it. This action is taking place against gravity. If you recall what is gravitational acceleration, you might remember that it is 10 meters per square second. So if anything moves vertically and they are asking to find the work done, don't forget you already know the acceleration is 10 meters per square second. So anytime they have given the mass, try to find the force using the F equal to ma. So let's substitute 5 kilograms times 10 meters per square second, which gives us 50 kilograms times meters per square second. So kilograms meters per square second is newtons. Yes. So the force applied is 50 newtons. So now it's easy. Let's find the work done. Work done is equal to force applied times distance moved. 50 newtons times 3 meters, which is 150 Newton meters, which is 150 joules. So that's how you calculate work done. In the next video I will bring you how to calculate energy. So thank you for watching the part 1 where we explain work done. See you guys soon in the part 2. Until then, bye bye.